Thank you, Sue. I'm Anton Athanayake. I'm an application engineer with KUKA. My background is in automation. I have been a controls engineer for the last 23 years, and I am not very old for the KUKA. I'm new to KUKA, so this would be my very first presentation for HMI Easy. So let's get going. What is HMI Easy? HMI Easy is a option package for KUKA that allows you to create custom screens for your application. And it allows you to modify, display variables, system variables, or application specific variables. You can use these screens to lock out certain people from entering or displaying these variables and use the controller login credentials. This entire application is programmed with the use of KUKA Work Visual. So you can create your application with Work Visual and download this to your robot controller. The actual name of this is KUKA HMI Easy. This is the version 1. And if you ever want to get one of these, you have the article number. You can contact your KUKA sales rep, account manager, and get a quotation so you can purchase one of them. If you want to get more information, you can get the information by going to expert.kuka.com. So let me get there. This is a website that KUKA hosts that anybody can get a login for free. You can get all the information about any KUKA products, software and hardware. So here, this is the KUKA HMI. You could get the documentation. This is a PDF file. You can get video tutorials, and you can get instructions for different functionality with this tech package. And ordering is simple. You can use the same login and go to mykuka.com and order this off the website. Or you can talk to your account manager and order it after getting a quotation. So that's where mykuka.com. System requirements. Our newest controller is KRC5, and it comes with the software version 8.7. If you are using an older controller, KRC4, you need a software revision of 8.3 or higher. 8.5, 8.6 is acceptable also. And you'll need a laptop to install Work Visual. If you download Work Visual, which is free off of Expert, you will get the version 6.0. So if you are doing this for the first time, you wouldn't have to worry about this. You will get the latest and the greatest software, and it should work. But if you're working on an older controller, then we have to make sure the software in the controller satisfy these requirements. Work Visual, I'm sure you have used it. If you've not, you can get a free copy of this Work Visual by going to Expert. Let's get there. And also, you'll see the documentation, instructions. Lots of instructions are there that you can use freely. And at the bottom, there is a link to download this. I already downloaded it and it's running. So we can go there and look at how to use this tech option. If you're doing this for the first time and have not installed the tech option, you can go to open Work Visual, go to Extra, click Option Tech Package Management, find your file, the KOP file, KUKA option package, and install it. So we can try to do that now. Here's work visual. Go to extras, option package management, click add, and then you go browse the new KUKA option package and select it and install it. I already installed it, so we don't need to do that. After installing it, you may have to restart your work visual. Then you connect to the robot and set the robot controller as the current robot controller. And under options, you should have HMI Easy option package. If not, you can right click the option folder, add, look for the option that you are you want to install, HMI Easy, and add it. I'm not going to add it because I've already added the option package. So this is where you add it. Before that, the folder could be empty. After adding it, you will have the option tech package. Then we'll go to the control elements. After installing this tech package, you will have this particular icon enabled. Click this, that's where all the screen management comes in. You can add a new screen, configure it, delete it, rename it, make a duplicate. You can import a new screen that is already completed from another application, or you can export it. So you can import it back to a different application. I have already imported it one HMI screen. Let's see, we can add a new one. So add a new one. You give it a name, double click this, and then you get this screen. Control elements, we have 11 control elements. And on the settings tab, let's go to this tab first. This is where you would set the columns and rename the tabs if you like. You can add tabs by right-clicking the bottom, add a new tab, and you can add up to 8 tabs. Under number of columns, you can have 1 column or you can have up to 4 columns. Each box, you can put 1 control in it. So there is a limited number of controls you can enter it into a screen. If you need more screens, you add new tabs so the operators can go to tab to get all the information they need. If you want to remove a tab, you can easily remove a tab. Under settings, you can add a name for the window that will appear here. You can make the screen display a full screen or a half screen. And then you can publish this screen in the display or the configuration tab. We'll get to that where it is. You can generate a menu item. So I have a virtual robot controller here. In this, you have the configuration tab and the display tab. You can decide where you want this HMI to generate a menu item. So you can select it here. If you select it in display, it will display the HMI down here. And whatever you want to name it in that tab, you can name it here. And the test one will be displayed right here. HMI Easy Main test one. This precision is sometimes important. Higher the number, lower that tab will be displayed in the menu. Right here. If it's 1000, it'll be down here. If it's 1, it will be all the way up on the top. So lower the number, higher the tab will appear. Higher the number, the lower the tab will appear. This is for auto starting. You can auto start a tab, and then you can change the tab to a different tab after certain minutes of inactivity, saying, hey, you uh, didn't do anything for the last 3 minutes. Now you have to restart the whole application or the process, and then navigate them through the settings back again. Now look at all the tech elements. We have 11 elements. Drop down, pretty self-explanatory. Image, you can display an image. Text block, this is more like a label that you can display a label on your HMI screen. Text box, that is a input control where you can input a string, number, or a real. Numeric, that you can have a plus and a minus sign. You can increment and decrement an integer. Slider control, that you can slide this control up and down, and that will change the integer value depending on the location of the slide. LED, LED is for displaying the status of a Boolean, inputs or outputs. LED on and off also has a on and off button on it. You can turn on and off a Boolean or output. Push button. Reference. Reference is a number mostly connected to an array that you can change the reference number by these two arrays, increment and decrement it. And we have an array display. Also, it has this array element, increment and decrement. Whatever the element that you select will be, the value of that will be displayed right on the right side. So let's go to each one of them and see how it looks like on the screen. You can bring in a drop down. When you click that control, then you have this property window comes up. You can choose where you want this to reside. You can drag to the box that you like, or you can change it here. And you can say how big you want it, 2 columns and 2 rows. And the drop down also have a header that you can change to whatever you want to show. Select something. And variable, all the controls has this variable. And this is important. All the variables that you can use here has to be global variables in the controller. You cannot use local variables in your programs. So in order to do this, I created a global dat file. So if I go to KRC programs, I created this global declaration file, which has a bunch of global variables that I'm going to be using in the lab. After you create them, you can just highlight it, copy, and paste that onto the variable, and that's where the link gets linked. You also have a required user level, access level. Anybody can use it, or different users can access these things. So for this purpose, let's make sure everybody can do this. Your user levels comes from here. This login button. Operator is for everybody. User, expert, safety recovery, safety maintenance, and admin. These are the logins. We can use these logins to give access to different parts of this display. Highest operating mode. You could make these active in one of these modes or all of them by selecting down here. You can say the robot's drive must be active if you want to make a change, or submit interpreter must be running if you want to select certain things. And here, the drop-down elements are here. So you can add bunch of drop-downs and have values in here. 1, 2, 3, 4, and 5. And then you can put these display text. That's what will appear when you select a drop-down. It will appear here. Whatever the value will get written to the variable that you select here. Image box. A lot of people use this image box to display certain things. Today we will use the image box to show the size, whether the gripper is open or closed. Same controls here. If you want to use image, you can click this and find your image and say open. And when you compile it, that image goes to the controller C drive, KRC, user, HMI Easy image, and 1.bmp. So that's what I have selected. When you compile and download it to the actual controller, these files get written to the controller. If you have multiple files, you can just find your files. Let's say you have a bunch of other files like this. You can select them and drag and drop into this image folder. Also, it has a variable. It's a string variable. And in the program, depending on the gripper status, you can select which image to display. Here's a label. It's simple label. It doesn't have a variable. You just type whatever you want to display. And you can make it in the middle, change the size, make this bigger, and this will be your text display. Numeric. This is also a thing that you can change a variable by incrementing or decrementing it. And you have limits here, 0 to 100, increment and decrement by 1. Or you can change this to increment, decrement by 10. And slider. Slider control. We'll make this bigger. Same thing here, just like the numeric plus minus. You can actually slide this control back and forth, and whatever the integer variable that you set will change. Or you can make it a real and then increment and decrement by 0.1 if you wanted, and change the limits from 50 to 2000. LEDs. Here you can have booleans that is globally defined, or you can just type the output or the input by typing out 2, that the output 2. You can decide what color it is. You got 3 colors, red, green, and yellow. You can make it in the middle, make it bigger, or you can show inputs if you like. In. LED on and off. Same thing here. This is output, so you can type out 5, and then you can use these controls to press to on and off. Either you can give it to everybody or maybe just for somebody with a higher login than operator. You could say, hey, I won't be able to do this only in T1 mode, not while it's running auto or auto external. If it's connected to a gripper, you don't want to close the gripper and open the gripper while the robot is running. And push button. The push button that you can change the name, have a Boolean attached to it, and then you can say whether when you press it, set it true or false. Reference. We will do a reference and array reference in the one that I have already created. So you can see a better example. After you do this, you save it and compile and download it. Before you do that, you want to make sure that it is creating a menu item in the display or in the configuration. Let's close this for now. And we'll remove this guy and look at the one I have created. So before we look at this, let's see what I have in the controller. So I have a simulation and I have a virtual controller. In the simulation is connected to the controller and it's, let me run it, and it's going to pick and place boxes from 2 conveyors. One has red boxes and the other one has blue boxes. It will pick one box at a time and place it in the outgoing conveyor. So after you do this, I want to display some of these application specific variables in the HMI. So it's going to continue to do this until it's forever for now. Let's go back to our work visual. I told you that all of these variables that needs to be globals. So the globals are defined here in a DAT file called global_declare. Here's a label, change speed. I want to be able to change the speed of the robot. So I have a variable name, ROBVEL, and anybody can change this. And you can change from 0 to 100, incrementing by 1. So if I go to the DAT file, you will see here is the integer, ROBVEL. Right now it's at 68. Next one is an image file. Maybe we'll remove this image for now and we'll talk about that image file on the other screen. Another label, and here I have a drop down. In this drop down, I have 3 values: 0 for red and blue, 1 for blue, 2 for red, because we are picking red and blue boxes. So what I'm doing is the operator will come and pick, oh, I want to pick this many blue boxes. And number of boxes that you can, I have used a control here to increment and decrement. I can go from 1 to 100, incremented by 1. And it is getting written to index limit, which is this index limit. And box count. the number of boxes it has picked and placed. The variable name is indexed1, which is here. We'll look at the code, how we use these things in a minute. Let's look at the next tab. Here's another label, push button called gripper open, linked to HMI gripper open, gripper close, HMI gripper close. Anybody can do this. And there is an image file, variable is string image, and this is a character array which will create the location of the image by the program. So it will pick one of these images. Here's output that I can turn on and off, and it's also connected to output 1. Output 1 is our gripper open and close. This is the reference. Reference index. Here's the identifier. Internally, this is a integer. When you can increment this and decrement this from 1 to 10. This value in this can be used for other controls, like this one. There's an output. Output and reference index, which is in here, reference index. Whatever the value that it displays here would be the output number. You can have math in here. This one says reference index plus 1, reference index plus 2, or you can say reference index times 2 plus 3. So if the reference index is 2, this becomes 7. So it will show the status of the output 7 in this display. Same thing for the inputs. Only thing that changes is this is an in instead of an out. This one, index plus 1, plus 2, and plus 3. Or you can display an element of an array like here. This is a text box display, but it is displaying a real value of an array. The array element comes from here, from this guy, this control. Whatever the element that is in here will get the real array element and display on this box. This is the array control. Same thing here. I have a real array, and in order to display this, this is how it shows the value here. Whatever that you select here, that value will appear here. So let's look at the code behind this.
Anton, we have a question.
Sure.
How could you set an LED to be either red, green, or yellow, depending on the variable status? It looks like it can only be a signal true or false.
Yes. It can be only a true or a false. So this can have either, if you select yellow, when it's true, it will show yellow. If it false, it will show this gray. You cannot have multiple colors. Okay. Any other questions so far?
Not that I see.
Okay. So this is the main program. All it does, it's a loop. Go through the loop, find out part selection. Remember, part selection comes from here. Part selection. If it's red and blue, it'll be 0. Blue 1, red 2. If it's 1, you are going to not pick the red boxes, it's false. If it's 2, you are going to pick the red boxes. If anything else other than 1 or 2, this will not get set, and it will pick the next color, the alternative color every time it goes to do the picking. It will pick red or blue, and then it do a place. I have here, let's do a cycle time count to see how it looks like. At the beginning, since it's a loop, at the beginning, I get the robot clock time into a integer, integer, and after placing, I get the robot clock time minus the previous snapshot time into the time cycle. Since it's millisecond, let's make this something useful, make it seconds. I will divide this by 1000. And this must be, if it's a local variable, I won't be able to use it in the HMI. So it needs to be a global variable. So let's say where it's declared. It's declared as a global. So I can use this. We go to the editor, catalog, text. I'm going to make this cycle time variable, and I'm going to say blocked. Blocked means I won't be able to change the value in it by clicking it. I'll be able to see it's written in here, but can't make changes. I think I have declared this as an integer, so I have to declare this as a real because I'm dividing it by 1000. After you do all of your changes, you can save it. Oh, forgot to talk about one other thing. Here's an array, and it is connected to real array. So let's look at that. Here's the real array, and it has 10 elements. I have put 1 to 10 in there, so we can look at them. I'm going to import another one that I have done earlier, HMI Easy. We'll talk about this after we've done the first lab. After you do this, you need to compile and download. So how do we do that? First, cancel the running program, log in as the safety maintenance technicians. After that, I am going to download. I can go next, 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 or I can say finish. It's going to compile, connect to the virtual controller, and download it. After you download it, you have to reboot it because you have downloaded new screens and it needs to create new tabs on the display. So after this is done, we can reboot this. Okay, now I'm going to reboot this guy. While it's rebooting, let's look at this screen. It's simple. It has a label, number of boxes it picked is the indexed one, and a button say good job. And the button is going to HMI badge act. If you look at the settings, it is not generating a menu item. So it will not create a link anybody can press to open this screen. And we'll get to it why I'm doing this later. And another thing I want to talk to you while this is rebooting. So some of these variables needs to update continuously. Some of the variables you want to use to set or read while a certain program is running. The speed of the robot, you always don't want something to be running to set the speed. Maybe you are trying to set the manual speed. So you cannot expect certain controls to work only when certain programs running. So in order to accommodate all these buttons to be displayed continuously, you had to create an asynchronous task. In order to create an asynchronous task, we use the same method that we use our submit program uses. This is our submit program. If you have done a robot, you know this is continuously running. You can create another submit program here by add, and by selecting this, create a submit program. So I created one right here. So it's in a loop. Set the variables at the beginning. I'll make the speed 50 at the beginning. It's a loop. Remember robot velocity that we set? If it's not the current velocity, OV_pro, make sure it is not less than 0. If it's less than 0, is set to 0. If it's greater than 100, set to 100, and then write whatever the velocity into the current override speed. Output 1 is our gripper open close. If the gripper is closed, you're setting the string image variable to this path, which will take it to gripper close image. C KRC user HMI Easy images close gripper.bmp. If not true for the output 1, then it will be open. Then I have another 2 buttons to gripper open and gripper close. I don't want to have a open button enabled while the robot is moving and picking up boxes while it's running auto cycle. I want this to enable only on the T1 mode, manual mode. So I can say, is the mode is T1, then I will satisfy whatever the operators press. If he wants to open it, I will say, okay, you can open it. If you want to close it, I can close it. Now it's open. Let's look at the submit. Submits are here. You can see this is running already. So in order to set this up, let's log in as expert. Let's deselect them all. Yes, stop, deselect. Here, this is already occupied. SPS is already running here. In this task, you can have your HMI Easy background task. And then if you reboot it, you want to make sure it is running when the robot powers up again. So you can select it here as well and make sure it auto start is clicked. That way, when the robot is rebooted, this task will start to run. When it is all good, we can select to run. And now it is running. Yeah, it's scanning. Since we downloaded this, now we can see display HMI Easy Main. So here it is. I can change the speed. You can change the overall speed is changing. I can change red box, blue box, or red blue. I can change the number of times we want it to pick. And I have the cycle time here. This one, I'm in T1 mode. Let's say I was in T2 mode. When I close the gripper, it will not accept this command. But if I'm in T1 mode, now I can close. When I close, the image changes. Open, new image. You can see these changes as well. And here, the indexes. I am displaying different values here. So let's go to input and output. Output. Output 1 is on now. I can select this and change it. Now output 2 is 1 is off. I can change number 2, number 3, and this one is 1 times 2 plus 3, that is 5. So I can turn on 5. But if I do this, now 5 is not here. 2, 3, 4. If I click another one, now this is 5. 3 plus 2, that is 5. This one becomes 3 times 2, 6, plus 3, 9. So if I turn 9 on, you can have that. Same thing with the inputs. Input 1, I have to turn on the sim so I can simulate this. This is the input 2. So the reason I want to show this, you could have a bunch of inputs and outputs that you have segregated, and you don't have to have all of them repeatedly named and addressed. You could use this reference to go from these sections of IO to display all of the IO that's segregated together. Here's the array that we have. Let's open this guy up. That's the array, real array. So element 2, 3, 4. Here's the first element here, but it's linked to this reference index. And the fourth thing, if you want, you can click this and I can say 4.444. And then if I get the actual values here, it should have written 4.444 here as well. And it's displayed here. Same thing here. I can change this to 777. If I go here to the 7th element, I should see this. Okay, now let's do a little test. Here's our simulation. I want this to pick Oh, I want to go to T2 so it will go faster. I want to acknowledge it is in T2 so I can control the speed to a higher number. I want this to pick 2 boxes, but only blue. And then I come here and I press run. So since I rebooted it, it lost the connection. So I click the robot, find to my connection, find this here, select this robot again, and it doesn't like it. So let's do this, see if I can reconnect it again. Seems somewhat happy. So here it's going to pick 2 boxes. And I'm going to display number of boxes it counted here. Display time is 12 seconds. 2 boxes. And you're done. So I want to do select, let's do red and blue. 3 boxes. You get the point. So you can just run this thing and have the operator select the batch count, different part types, number of parts to pick and place or do certain things by letting a operator use these easy to see and understand screens to do things. The simulation didn't pick that box. So after the 3rd box, it should stop. Okay, so it's done. We created a lab. Any questions so far with the first lab?
There are no more questions right now.
Okay, so let's go on to doing something little different. All of these functions here are in the KRL code that you can call and display a screen that you already created. You can display a specific screen and a specific tab by calling these. So I like to use some of this to create an application, to improve this application that I already started. Since this is already been downloaded, we can go to online edits. Go to the programming and diagnostics, click this, and then it highlight this controller here. Establish the controller state, which will bring in all the code that is in the controller. And I like to make some changes to the main. So we pick and place boxes. And at the end of the box picking, I want to say, hey, you completed this. So I want to open a new screen that is not displayed in here, that you in this configuration or in the display. Remember, I downloaded another screen here. This is not being published. It is in there. I want to call this after the end of the cycle. So in order to do that, we are going to write some code.
Hey, Anton, are those KRL functions in 8.3 or just 8.6?
8 point, let me get back to this. 8.3.18 and higher. So if it's 8.3, it might not be there. So I've written some code. I'm just going to copy this and plop it on here. So it will be faster. What it does is it finishes the picking and placing. After the count is done, it exits the loop and it starts another loop. There's a reason for the loop. You don't need a loop. You can just say display this HMI, new HMI, and wait for this button to be pressed. But remember, you can close this. If you have this screen, you can close it. If you close it, then your program will get stuck. So I put this in a loop to constantly find out the screen that you open is actually still open. If not, you're going to make him open again. And it's going to stay here until this HMI badge act button is pressed. So I put this code in there, and then I'm going to download the code, save and change. Go here, acknowledge this, and it didn't take, so I'm gonna try it again. Upload. Yep, it worked this time. Okay, here's my simulation. My speed is 0, so let me change my speed back to 100. Changes to just red boxes this time. It's gonna pick 3 boxes, and it should end with a screen to acknowledge. Here's my screen. It says pick 3. So when I hit good job, it should end. But accidentally, if I close it, it should reopen this again, because it could happen. Somebody could go in there fat-fingered and close this. And if you don't bring this back here, and your code's going to get stuck. So now I can say done. After it's done, it goes home and end the program. So there are various methods you can use to make sure the screen is running. I used in my code, we use HMI Easy View is open. Here's the name of the HMI screen. If we go here, you will see that's the name of the screen. And it's a Boolean, returns a Boolean value. If it's not, I am turning it back on, opening that tab with tab 1 with this specific screen. And if I get this input Boolean from the screen, I can close this HMI Easy Close View. I'm giving a specific name, so it will close the specific HMI screen. After that, I can exit out of the loop. Any questions?
I see no more questions in the question area right now.
Okay. That's all I have.
Industrial intelligence.